In previous videos, we saw how the number of digits in your number is significant and that having more digits in a number does not necessarily mean that the number is more accurate or precise. Thus, it is important to know how many significant figures we should use in order to accurately reflect the true value or precision of the number. This is particularly true when doing calculations and using a calculator, so rounding off numbers is important. Imagine that you wanted to know what the volume of a Rubik's Cube is. Suppose you measured each side to be 5.7 centimeters in length. So what's the volume? If you use a calculator, you would have multiplied 5.7 by 5.7 by 5.7 centimeters to get 185.93 cubic centimeters. Is it reasonable to claim that the measured volume is precise to the nearest thousandth of a cubic centimeter? Hardly not. It seems quite unreasonable. Yet, that is what the calculator shows. Each of the lengths that you've measured had an accuracy of 2 significant figures. So you cannot claim to have an accuracy of 6 significant figures. At best, you can only claim to have the same number of significant figures as your measurement. In this case, it is 2. So your answer should be written to 2 significant figures. That is, the volume of the Rubik's Cube, according to your measurement, must be rounded to 190 cubic centimeters. In general, when multiplying numbers together, the number of significant figures that should be kept is no more than the least number of significant figures in the numbers that you are multiplying. Let's have a look at another example. Consider multiplying 2.4 by 3.42. The answer is 8.208, which has 4 significant figures. The first number has 2 significant figures, while the second number has 3 significant figures. Given that the least number of significant figures is 2, our answer needs to be written to 2 significant figures. Thus, our answer needs to be rounded to 8.2. This rule of least number of significant figures when multiplying also applies to divisions. Now have a go at rounding the following number as practice. Now imagine measuring the length of 2 planks of wood. One plank was measured to the nearest centimeter to be 9 centimeters using a ruler that has centimeter scales. The other was measured to be 9.2 centimeters using a ruler that has millimeter scales. You add the 2 lengths together, and what is the total length of the 2 planks? The answer is 18.2 centimeters. But is this answer accurate? We see that the first length, 9 centimeters, was made using a ruler with centimeter ruling, so it is accurate to 1 centimeter, while the second length was measured using a ruler with millimeter ruling, so its measured length is accurate to a millimeter. We can see that the centimeter ruler is the least accurate. If we keep the answer as 18.2 centimeters, we are saying that the answer is accurate to 1 millimeter. This cannot be true, as one of our lengths is only accurate to a centimeter. Making the answer more accurate means that we have arbitrarily increased the accuracy of one of the measurements and have made that measurement more accurate than it really is. Given that the first measurement has an error of plus or minus 1 centimeter, then it is logical that this error is carried through to the addition so that the total length also has this error. Our result cannot be more accurate than the least accurate number. Thus, our answer is written to an accuracy of 1 centimeter. That is, our answer is rounded to 18 centimeters. Now have a go at the following quick quiz. So we can see that sometimes in our measurements and in calculations, we need to round off numbers. When rounding off numbers, there is a simple rule and that rule is to round to the nearest least significant digit. Let's have a look at a few examples. Consider the number 2.4132. The number has 4 significant figures, and we want to round this number to 2 significant figures. This means we need to keep the first 2 most significant digits. They are the digits 2 and 4. To determine the rounding, we look at the next digit after the least significant digit in our rounding, in this case, the digit 1. If this digit is less than 5, then we drop this digit and all other digits after it. Our rounded number then becomes 2.4. If instead the number was something like 2.4632, and we still want to round the number to 2 significant figures, we still check the digit that is next to the last significant digit to be kept. If it is 5 or more, then we round the last significant digit up and drop everything else afterwards. Our rounded number then becomes 2.5. Try the following quick quiz. In summary, the number of significant figures that you keep will depend on the arithmetics of your calculation. If you're multiplying or dividing, your answer cannot have more significant figures than the least number of significant figures in your calculation. If you're adding or subtracting, your answer cannot be more precise than the least precise number that you have used. And a final note on rounding. When you're completing a calculation involving multiple mathematical steps, only round off at the end of the calculation and not in the intermediate steps.